So what you're looking at here is a concurrent force system. And what that means is all our forces will pass through the same point right there, highlighted in blue. Now, what we're required to do here, we need to be able to find the magnitude and the direction of our resultant forces. In addition, we need to be able to find the equilibriant force and the angle and all of those things, which I will break down step by step for you. Now, the first step is for us to be able to understand how to calculate force components. And what that looks like is we'll have two sets of force components. So for example, if we have a force like that going off on a tangent, that force will have two components. And I'm just doing a little dotted line there that will represent our reference horizontal line. So for the horizontal force component, in this case here, that will just simply be force, cos, and the angle, and our force will be given. This will be much clearer when we're doing the question. Now, the second part, vertical component, is just going to be force, sin, and angle. And that's it. That's the calculation. We just need to really put this together nicely, and then you'll start to have really high levels of confidence with it. Now, that's part one done. That's the first thing we need to do. The second thing that we need to know is how to understand if our force components are either negative or positive. And this bit is going to be straightforward. If you have done any form of coordinate graph before, you will know that your x and y values here are both positive, and it's the same thing for our force components. Any force going up and to the right, the vertical component will be positive as well as the horizontal component. So in this case, we have a positive horizontal component and a positive vertical component. If we look down here, if we have a force going like that in that direction, then it's still going to the right. So therefore, our horizontal component is positive. But because that force is going down, it means our vertical component will be negative. Now, how about on this side? Again, it's going down and going to the left. So what that means, our horizontal component will be negative, and our vertical component will also be negative. Why? Because it's going down, and once it's going down, vertical is negative, and if it's going to the left, horizontal will be negative, just like this one here. So we have horizontal component as negative, vertical component, because it's going up here, vertical component will be positive. And these are the only two main things that we need to know in order to solve this question. And we're going to get right into solving the question now. So the first thing that we're going to do is to evaluate, first of all, the component forces. And I'm just going to clear a little space there, and we're going to get cracking with that. Now, to do this, I am just going to sketch a table to really organize the information that I'm going to work with. So on this column, I'm going to have the forces. On this column, HC will stand for horizontal component, and over here, VC, as expected, vertical component. Now I'll go force by force, and the first force highlighted here in yellow is F1, and for that force, it's 5 newtons. Now, that force is one of the exceptions, and why it's an exception is because it's a force that's purely vertical, so it's neither going left nor right. And what that means for the horizontal component is that it's 0. So 0 newtons will go there, and for the vertical component, it's just going to be as is. It's going up, so it's a positive 5 newtons. And that's it. That's the first component done. Now, on to the second one. I'm going to go to F2 next. So that's our F2, and it's 8 newtons. And the angle we're working with there between the force and the horizontal axis there is 30 degrees. So this is how that will look. So we have that 8 newtons. And then it's the same system we're going to use. We're going to do 8 cos, and the angle is 30 degrees. And all you have to do now with that 8 cos 30 degrees is put that in your calculator to get the actual value of it, which is 6.93 newtons. So that's that component there. Then we go across, it's just going to be 8 sin 30 now for that same component. So the value of this now, 8 sin 30, is just going to be 4 newtons, because sin 30 is 0.5 or a half, so therefore that's 4 newtons. So that's that force done, and on to the next. So the next force that we have, it is force 3, 6 newtons, and the angle for this force is right there between the force itself and the horizontal axis there, or reference, and we have 60 degrees for our angle. So our force, 6 newtons, and we're gonna keep the same system, but this time around be mindful that this force is going down and it's going to the right. So for the horizontal component, it will still be a positive 6 cos 60, and when we put that in the calculator, cos 60 again 0.5, so therefore this is 3 newtons. And we come across now, because this is going down, it's going to be negative 6 sin 60. And it's only negative particularly because this force is going down. So negative sin 660 turns out to be negative 5.20 newtons. So that's that one there done. And on to the next one. So for this one, what we have that 10 newtons. So I'll highlight again so you're tracking. So that's that 10 newtons, and the angle there is between the force and the horizontal reference there, so 60 degrees. Now to do the calculation, it's going to be more of the same. So we have the force, so that's 10 newtons. So it's going down and it's going to the left. So that means because it's going to the left, horizontal component will be a negative. So that's negative 10 and cos 60. And when we put negative 10 cos 60, we get negative 5. And over here is just negative 10 sin 60. And put that in, we get negative 8.66 newtons. So that's our values there. And we're going to end slightly similar to how we started, where we have an exception to the rule, where in this case our force 5 is 3 newtons, and it's just a purely horizontal force going off to the left. So what that means is that force, its value will be negative 3 newtons. It's not at any angle. And for the vertical component, it's 0. What we have to do now with this information is sum the column with our components. So what we're adding is the actual totals that we have for the calculations. So this here is our 6.93 that we're adding to 3, to negative 5 and negative 3. And when we sum those bits up in our calculator, we get 1.93 newton, and that's representing the sum of our horizontal components. And if we go across now to the vertical components, we get 5 newtons plus 4 newtons minus 5.20 minus 8.66 newtons, and that turns out to be negative 4.86 newtons. And that is representing the sum of our vertical force components. Now, what we need to do with this information, this is what's going to allow us to now calculate our resultant and our equilibrium, as well as the directions. So to do this, I'm going to keep it straightforward. I'm going to keep it very simple. And all we're going to do is to just consider these values as coordinates. So this is representing our vertical axis or horizontal axis. And this 1.93 goes on our horizontal axis right here, 1.93 newtons. And that negative 4.86, it comes down here, because it's negative, as negative 4.86 newtons. And what that means our resultant will be in this quadrant right here. So this capital R will represent our resultant, and its direction is this angle that we need to find. And this might look a little bit intimidating somewhat, but it's pretty straightforward, because what we'll end up with here is a simple right angle triangle. So right here is our 90 degrees, and the 1.93 that we just calculated, it's actually the length of this side. We can consider it to be the length of this side, and the 4.86 goes right there. If you can already identify that this side, highlighted in blue, is actually an hypotenuse, and what that means for us is we have these two short sides, and we're now finding this hypotenuse. So to do that, we're going to just square root this 1.93 and square it, plus that with our 4.86, which you can put as negative, because when we square it, it's just going to be positive anyways. And that turns out to be 5.23 newtons. So if you're asked what is the magnitude of your resultant force, then right here is the answer, this 5.23. So now you need to find its direction, which is the angle that we don't know yet. And again, we're going to apply some trigonometry to this. So this is our angle, and across from our angle is always going to be our opposite side. And if this is our opposite side here, then this is our adjacent. So we're working with opposite and adjacent here. And the trig ratio that we use there is tan. So what we'll do to find the angle is tan inverse opposite, which is our 4.86, divided by adjacent, 1.93. And it turns out that our angle is, pop that in the calculator, 68.4 degrees. So that's 68.4 degrees. If you were to consider the negative there, you can put it in as negative, which would suggest that it's just beneath our reference horizontal line there. But in this case, because we're representing it graphically, you don't need to. So right here is our direction, that's 68.4 degrees. So the only thing that we have left now is to work out our equilibrium. And to do that, we're just going to take the short way out, which is just extend that same resultant line. And this represents our equilibrium, because the force will be exactly the same. So the equilibrium value will be the same value as our resultant. So that's 5.23 newtons. So it's the exact answer. And then the angle right here is also going to be the same, which is our vertically opposite angle. So this angle right here for our equilibrium force right there, I'll just put E angle, is the same as our angle there for resultant, which is that's 68.4 degrees right there. And if for some reason you need to measure it counterclockwise, that equilibrium angle, you just need to subtract the value that we have there from 180. So that would just simply be 180 minus 68.4, which will give us 111 point something, 111.6 degrees. And that's it. So what we have so far, I'll just check off everything that we have calculated in green. So what we have the resultant right here, its magnitude. So that's the magnitude of the resultant. This here is representing the angle, and the equilibrium is the same value as our resultant, the magnitude of the equilibrium. And our angle right there, equal and opposite, or vertically opposite in this case. And if you want to find the angle counterclockwise from the reference here, It's just to subtract from 180, and that's it. It's all done. So please subscribe to the channel, like this video, help me out to grow this channel because I want to help as many people as possible reach a wide audience, and I will see you in the next video.